Welcome back, everybody. Today we're going to review a little bit and also learn a little bit more about acceleration. Acceleration is the change in velocity over a change in time. If you remember that there's a difference between velocity and speed, speed is simply how fast you're going, and velocity is how fast you're going in a certain direction. So you're going to have a little bit of a difference, but really the math works the same way. Your speed or your velocity will have the same. So if you were to take velocity, you're going to have the change in distance over the change in time. Okay, change in distance. Remember, you could also call that displacement, where you're starting and where you're ending. Acceleration is the change in velocity over the change in time. Okay, now look at this. This is an excellent a study guide here that I've got that I stole from someplace. They make a point here that acceleration, they use speed instead of velocity here because they'll make a distinction later between speed and velocity, but they use S for speed. Acceleration is the change in speed over the change in time, not speed over time. So their example for speed over time, if a car is traveling 60 miles meters per second for 20 seconds, the speed is 60, but the change in speed is 0 because it never changed. So in order to accelerate, you have to change your speed. Something has to change. You have to either change your speed, or in the case of velocity, you have to change your direction. Either way, you're going to accelerate. So if you don't change your speed or don't change your direction, you'll have no change in velocity, and so it will not accelerate. So let's look at a couple examples. So here's your formula. A equals change in velocity over change in time. This is acceleration. They showed you that the change in velocity is going to be whatever your final is minus whatever your initial is. So if you go up to 100 but started at 0, it would be 100 minus 0. If you're starting at 100 and you go starting at 100, that's your initial, and you go down to 0, it would be 0 minus 100, and your velocity would be negative, and that would be slowing down or decelerating. Change in time, wherever your last time is minus whatever your first time is. A lot of times you can elapse that from 0 if you want. Okay, so here's an example of calculating acceleration. A plane starts at rest and ends up going 200 meters per second in 10 seconds. Come calculate the acceleration. Well, if you remember, acceleration is the change in velocity over the change in time. Well, the change in time is 10 seconds. So we can say that this all happened in 10 seconds. How much did it change its speed? The speed has to change. That's what change means here in the delta. So it starts at 0 and ends at 200 meters per second. Okay, so velocity final minus velocity initial. Final is 200, and initial starts at rest. So it's going to have a change of 200 seconds, and then 200 meters per second, and it changes in 10 seconds. So you're going to have 10 into 200, which is 20, and your answer is meters per second per second. So you're going to have a unit of meters per second squared for acceleration. Okay, meters per second squared, because it's meters per second is the speed per second. It's speed change per second, so it's meters per second, and that's why there's 2 seconds on the bottom. Here's next example. A race car starts at 400 meters per second and then stops down to 0 in 20 seconds. What is his acceleration? Now you're actually decelerating, okay, you're slowing down, but that's still accelerating. It's just a negative number. You're going to end up with a negative here to show you that you're decelerating rather than getting faster. All right, so let's look at change. Acceleration is change in velocity over change in time. Change in velocity is, what is the final? The final velocity is 0. Okay, so you're going to have 0, and then the initial is 400. Okay, so 0 minus 400 is going to give you velocity, or the change in velocity equals minus 400, and then divided by the change in time, 20 seconds. So 420, so 2 into 4 is 2, and then that cancels, and so you're going to end up with 20, but your answer is negative. So it's acceleration is 20, and this is meters per second, and this is seconds, so it's 20 meters per second squared. Okay. All right, so average speed is the entire distance that you travel in the entire time. Okay, so a person walks 4 miles in 2 hours, then stops for an hour. After lunch, they walk 8 miles in 3 hours. Calculate the person's average speed. So it's 4 miles in 2 hours, and 8 miles in 3 hours. But there's an hour in here where there's no distance. There's nothing traveled because they're stopping, but the time is still going on. So how many miles did they travel? 4 plus 8. So there's a total of 12 miles. And then how many hours did it take them? That's 2 and 3 is 5 and 1 is 6. Is 6 hours. So it's going to be 12 divided by 6 is 2 miles per hour. Okay, that's the average speed that you have to take into all time elapsing, even time when you're not moving. Okay. The last thing that they say here is speed is a velocity, speed versus velocity. I need to talk to you about two terms, vector and scalar. If you have the number 10, okay, that's a scalar. It has magnitude. It's more than 0, or even 0 would be a scalar because it has magnitude. There's a how much part of it. When I see a number there, I can see how much. And then if you give me units, I can make more sense of it, how many pounds or how many minutes or how many miles or whatever. If you have 10 meters, okay, 10 meters, that's a distance, okay, but that still only tells me how much. So scalar tells you how much. If you have 10 miles an hour, that still only tells me how much, or meters per hour, or miles. I'll put miles here. 10 miles per hour, that's telling me a speed, which tells me how much, but it doesn't tell me anything else. Vector implies direction. If you're a vector quantity, you have a direction involved. If you're a scalar, you only have amount. You only have how much. But a vector is going to have both scalar and vector together. So if you have a direction, then if you have an amount, a magnitude, this is called a magnitude, how much here, 10 miles an hour, and you have a direction, north, suddenly that's a vector. If you only have a magnitude, 10 miles an hour, or 10 miles, or 10 hours, whatever, or just the number 10, that is just a magnitude, and so it's a scalar vector. Okay? So a person walks 4 meters per second. Okay, that's a speed because it has no direction. So speed is scalar. Okay, a person walks 2 meters per second north. That's velocity because there's a direction. So velocity is a vector, speed is a scalar. SSVV, real easy to remember. Most people don't mess that up. Vectors have magnitude and direction, and so velocity, usually you're going to have an arrow above it because velocity is showing you that it's not just miles per hour, but it's miles per hour in a certain direction. Also, since velocity is change in velocity over change in time is acceleration, acceleration also is a vector because direction is implied in velocity. You can change your velocity by going the same speed but turning the steering wheel. If you're changing direction, you're actually accelerating. You can feel this when you go around a curve. Don't get faster, but if you do not put on the brake going around a curve, you can feel the acceleration of your body as it leans to one side in the car. Okay, so let's do a couple of these examples. Speed or velocity. A bike goes 25 meters per second towards Main Street. Towards Main Street's a velocity because it's a direction. A person walks 4 miles an hour. You should be saying it in the head. That's a scalar because it's just giving a magnitude. A plane flies 200 meters per second. That's scalar. It's just a magnitude. A bird flies 100 miles per hour due south. It's pretty fast. That's a vector. Okay, or it's a vector, so it's velocity. Sorry, I meant velocity. Scalar or vector. Does it have magnitude or magnitude and direction? 40 miles per hour towards Dallas. That's a vector because it has direction and magnitude. A 25 Newton force pulls on a wagon. Well, that's scalar. It has tells me how much force, but it doesn't tell me what direction that force is in. So that's scalar. 10 meters up the hill. That's a scalar factor, and this is the vector part of telling you direction. So that's vector. 12 meters per second squared, that's scalar. It's just telling me an amount. What are the units for acceleration? The units for acceleration are meters per second squared. So it's going to be this one, 3 meters per second squared. Meters per second squared. How about speed or velocity? What's the units for that? It's going to be some distance over some time, so 23 meters per second. How about, so this is mass, m is mass, so 23 kilograms would be mass. I'll abbreviate that. D is distance, I suppose, so that's a length, so I would imagine 23 meters would be a distance. F is force. Force is measured in newtons, so newtons is a force, 23 newtons, capital. And then T is time, and so we want 23 seconds. Okay. All right. A person starts running from 2 meters per second to 6 meters per second in 2 seconds. What's the person's acceleration? All right, the formula is A equals change in velocity over time, or change in time. So you're going to say, what's my change in velocity? What's my final velocity? 6 meters per second minus the original 2 meters per second divided by the number of seconds it takes, 2 seconds. So this is 6 minus 2 is 4 meters per second over 2 seconds. Okay, so you're going to end up with meters per second squared, and it's 4 divided by 2. So your answer is 2 meters per second squared. Your variable, okay, your variable is going to be velocity and time. A plane stops from 250 miles an hour in 25 seconds. All right, so if he's stopping, this is decelerating, you're going to get a negative number. So you're going to have, if you'll remember, A equals change in V over T. And you have the final velocity. Final velocity is 0 minus initial velocity is 250 miles per hour. And it's going to happen in 25 seconds. So this is going to be a negative 250 miles. Now this is going to be weird. It's miles per hour. Okay, miles per hour, and it's going to be over 25 seconds. So this is going to cancel, and you're going to get 10 miles per hour every second. How fast did it decelerate? It got slower 10 miles an hour every second. Okay, now that's weird, 10 miles an hour a second. Normally you would probably put this in seconds and then make it miles per second squared or meters per second squared or something like that. Okay. A guy bikes 15 miles in 1 hour, then rests for an hour. He bikes 25 in 2. What was his average? So let's add up all of his miles. 15 and 25. So 15 and 25, 35, 40. Okay, so it's 40 miles and 2 hours. So your answer is going to be miles per hour. 40 divided by 2 is 20. And so it's mph, miles per hour. What was his average? Okay. A dragster's top acceleration is 60 meters per second. If he accelerates for 3 seconds from the starting line, how fast will he be going? Let's assume that he's going this full acceleration. Okay, so A equals change in V over T. Acceleration we know is 60 meters per second squared. The final velocity we don't know, so that'll be final velocity. Initial velocity is 0, and he's going to do it in 3 seconds. So we want to solve for V sub f, or final velocity. Well, this goes away. 3 multiplies, so 3 times 6 is 180. Okay, 100, and that seconds cancels with one of those, and so it's meters per second. And that's final velocity. He finally is going 180. Okay. What is the acceleration for this graph? Well, remember, acceleration is change in velocity over time. So how far? Let's pick one where it goes over the grid line. Right there's one. Here's a point and here's a point. So in 10 seconds, he gets faster by 60, from 0 to 60. So he goes 60 meters per second in 10 seconds. 10 into 60 is 6 meters per second squared. And I love this. Which graph segments fit the following? Constant speed. Okay. So as time is passing, this speed is staying the same. I gotta see if you can see that. A would be constant speed. What's happened when he's decelerating? As time is passing, he's going down in speed. That's deceleration, so that would be B. Accelerating, as time is passing, he's getting higher in speed. He's going up the graph as time is passing, so it's a tilt up. This would be D. And then we've got C. Is C constant, deceleration, or acceleration? It would be constant. Okay. The slope of position versus time graph means, okay, the slope of it is going to be how fast. Well, it's acceleration. It's the change in velocity, so it's acceleration. The slope of a speed versus time graph means it's also, position versus time, I'm sorry. Position versus time is changing distance, so that's velocity. That's how fast I'm moving. But a speed versus time, this is going to be acceleration. All right, thank you.